Hello, welcome to this video, and today we will be talking about the strategy pipeline. As you can see in the orange, we have the strategy, which is communicating using the other robots, using robot state, and upon knowing the poses of the object and the pose of the robot, and the game state, we're sending the robot go, which is a position go, and a command, which is like where the robot is going. So all of the code pretty much lies here. So as you can see, the main entry function is main. It initializes the node and starts the game engine 3D. So we have two game engines. One is the 3D and one is the 2D. The 2D is more of a simulation. So let me just show you what that looks like, for example. Okay, it did not have any visualization, so to fix that, display. So this is a little 2D display. This is a 1v0, 1v nothing. You can see as the robot is executing a strategy we call the dummy strategy. It just keeps walking towards the ball, and it's not paying attention to the enemy robots whatsoever. It just and it makes these paths shown by the white lines. It goes towards the ball. So all of that can be expressed in the game engine 2D, and then the game engine 3D. So the game engine 3D and the game engine 2D. The 3D one is the one that actually connects to the rest of the stuff in ROS. So let's just, for example, start from the main function. So it initializes the robots, the team, and information about the 4 other robots. It's assuming that team 1 is the strategy that we are using and team 2 is the opponent's strategy, and it listens to the game state here. So the way after initializing, it goes to this run function, the main loop of the function. It first decides what strategy to take. So this function does nothing other than listen to the game information, whether it's ready, and decide which of the strategies. All the strategies are located in the strategy folder that we want to undertake. So after deciding the strategy, it will run the strategy loop, and it will log the team information, and then it will update next strategy. Yeah, it will run the update next strategy. So what is passed into the update next strategy function? Self.team1 and self.team2. Self.team1 is a team of robots, and team2 is another team. So a team of robots consists of the robots themselves. So as you can go back here, robots are created here, a team, and then the opponent team, assuming that we don't care about the opponent's team information at the moment. So the team of robots have the ball position as determined jointly by the team of robots, which field side it is first half strategy the team is using, and formations. So formations you can see here, and then the enemy goal position. So we have some functions like flip position, which is the goal position is different. Update average ball position, checking taking the average of what all the robots think the ball is, and then the log function. So what is a robot? So we have robot, robot controlled, robot controlled 2D, robot controlled 3D, and robot observed. So what is the hierarchy tree? So robot is basically some very basic information about a robot. Its team color, row, status, and just some like basic stuff. And robot observed is just a robot, except it has a subscriber which will update the information in robot. And robot controlled is the 3D is the opposite of the observer. So if a robot observed is, like for example, I'm robot 1, robot observes, I have robot 2, 3, and 4 are robot observed, and myself is robot 1, which is the robot controlled. And then robot controlled also depends on 2D and 3D. If it's 2D, which is the simulation I showed you before, then it's using the game engine 2D. If it's 3D, which is using the Weebots in real life, then it's also using 3D. As you can see, it contains a bunch of publishers and subscribers in Robot Control 3. I recommend you take some time to understand some of the functions here. So let's go back to Robot Game Engine 3D. So every number of seconds, we decide on how often it loops. The loop happens based on the update frequency of the strategy. So, for example, strategy dummy has an update frequency of 1 second. And there are other strategies. As the moment, the only strategies that are important are strategy ready, which is walking the robot to the center of the field in the beginning. Strategy determined side, which is in the beginning of the game. The robot needs to know which side it's on. After strategy determined side, it goes to strategy ready, which what makes the robot walk to the position as given by game engine. Sorry, as given by the team configurations here. After ready, it goes to strategy set, which is nothing. So there's a moment in the game where the robot should not do anything and allow the humans to check that everything is ready. And then after ready set, it goes to the strategy dummy. This is just a greedy strategy where we walk towards the ball, and if we look for the ball, see the ball, walk towards the ball, kick the ball through the net. And if you don't see the ball, keep rotating around. This is basically the main strategy, the main code for a single robot. There are other stuff like here, like strategy free kick, strategy penalty kick. These have not been tested at the moment. Strategy stationary basically do nothing. And pretty much it's not that complicated. There's also decision tree stuff here. This is in the work, but it's not tested thoroughly yet. So also we have communication. So this is actually its own node. As I go back here, this is the game controller receiver. Perhaps Jonathan explained. This takes in the game controller information and publishes a ROS topic with the game controller information. And then team communication subscribes to robot 1 / information about robot 1 and broadcasts it to 2, 3, and 4. And it does the same thing for 2 to 1, 3, and 4. So basically every robot has all the information about the other robots, and that information is in this message here, robot state. which is like what is the robot doing, what's the row, what's the position, and of the ball. Also row, like some of the rows are automatically determined in the beginning. They're not hard coded. The position of the robot at the moment and where it thinks the ball is. And using all of this information. That's basically all the information. Oh, and player ID, of course. And game state, if Jonathan explained, tells you whether it's initial, ready, set, playing, finished, and this other secondary state. We can take some time to read about this on your own. Okay, thank you for listening to this video. Hope this is informative. Yeah, I'll see you next time.